All right, folks, welcome to part two. On this, we're going to look at these conversions here. So we're going to try to convert grams of oxygen into moles of oxygen. So for this, we're going to use our molar mass of O2. So we're always going to start by writing what we're given. And then this is going from mass to moles. So we need to know that 1 mole of O2 is equal to twice the molar mass of just one oxygen atom. I think in class I've done this for you. It's going to come out to be just under 32. So if I just do 2.72 divided by 2 divided by 15.9994, this should give us 0.0850 moles of oxygen. All right, easy enough. Here we're going to go from formula units to grams, in this case of iron 3 chloride. Again, with this, it'll probably be handy to, since we've got a mass involved here, find our molar mass for that substance. So we're going to take our 7.32 times 10 to the 25th formula units of iron 3 chloride. And we could stop at moles in the middle, but I think it's going to be much easier if we just go right from our formula units to our grams, because our moles are going to end up canceling. So if we have 6.02 times 10 to the 23rd formula units of any substance, in this case iron 3 chloride, we're going to have our molar mass of that substance, again in this case iron 3 chloride. This number that I'm getting up here, this is what we end up if we sum together our molar mass of iron and 3 chlorines. This is our molar mass of iron 3 chloride. So that's going to be in grams of FeCl3. That should be more uppercase looking there. So I'm just going to multiply this number times this number and divide by Avogadro's number down there. And this should give us 197 point, actually if we look at our sig figs, 3 is all we need, 197 grams of iron 3 chloride. Looking down at our next one here, this is dealing with liters, and if you remember the relationship between moles of a substance and liters of a substance, any mole of a substance is going to take up, any mole of a gas is going to take up 22.4 liters at standard temperature and pressure. So we're going to do 84.23, it doesn't look like a 3, there we go, 23 liters of bromine gas. And we want to change this to grams of bromine gas. So 1 mole of any gas, we said, is 22.4 liters. And we're just going to put up here our molar mass of bromine. That's 2 times the mass of bromine, 159.808 grams per mole. And if we do this, we do the math here, we should end up with about 600.9 grams of bromine. And then our last problem here, C6H12O6, good old carbohydrate, we might remember from biology as glucose. So we're going to take 97.23 grams of glucose, and we want to change it to molecules of glucose. So we know what's my relationship between molecules and particles, or moles. In this case, 1 mole of a substance is going to be equal to 6.02 times 10 to the 23rd molecules of glucose. And what's the mass of 1 mole of a substance? It's its molar mass. So here, how many grams is 1 mole of this? Well, 6 times the molar mass of carbon plus 12 times the molar mass of hydrogen plus 6 times the molar mass of oxygen. This will give us 180.158 grams of C6H12O6 in 1 mole of C6H12O6. But how many particles are in a mole? Oh, that's right, 6.02 times 10 to the 23rd, in this case molecules. So our grams of C6H12O6 are going to cancel out, leaving with just molecules. And if we do the math here, we should end up with 3.24 times 10 to the 23rd molecules of C6H12O6. Alrighty, that concludes it for part 2.